stratosphere. The important facts about stratosphere is ozone concentration is maxima in stratosphere around 25 to 30 kilometer. This is a very interesting and important point about ozone, that ozone maxima is found near about 25 to 30 kilometer in stratosphere. And in stratosphere, the temperature increase with increase in height as opposite to that of troposphere. This layer is present, ozone layer, and it is important because of the two reasons. The reason number one is ozone layer is present in stratosphere, and this layer is devoid of water vapor because we don't have any hydroxyl radical or water vapor, or the negligible amount of hydroxyl radical or water vapor here. That's why no weather phenomena can be observed in stratosphere, and this is the reason that why our fighter plane or jet plane prefer stratosphere layer for flying purpose, because they need maximum visibility and minimum resistance. And the normal airlines or the flights which we take, they generally fly in troposphere. Okay. Then we have another classification of atmosphere, which is very trivial sort of classification, which is like we can divide our atmosphere into two spheres. One is called homosphere, another one is called as heterosphere. Homosphere, if we see, ranges from 0 to 80 kilometer on the earth surface, and here the composition is almost same, means the gases are well mixed. If we talk about heterosphere, heterosphere ranges from 80 to 90 kilometer, and composition is not constant. We have different gases which are there in different layer and are not well mixed. And in this series, we have 4 different layers which are designed depending upon the density of the gas molecules. For example, the heavier the gas, the bottommost position it will take. So the first layer we have is the N2 molecular layer, because the molecular mass for N2 is 28 gram per mole, and it is seen at around 200 kilometer. The second layer in this series is oxygen atom layer, because the molecular mass or the atomic mass of oxygen is 16, which is seen at around 1100 kilometer. The third layer is helium, having a molecular mass of 2, which is seen at 2600 kilometer. The fourth one at the lightermost will be at the top, hydrogen atom layer, which is seen at 9600 kilometer. Most part of the heterosphere is in thermosphere. That point needs to be remembered, that most of the heterosphere lies in thermosphere. In thermosphere, there is a layer which is called as ionosphere, which ranges from 80 to 250 kilometer, and this is the lowermost part of thermosphere, means ionosphere is the lowermost part of thermosphere. And in ionosphere, what happens? Nitrogen molecules and oxygen atoms, they absorb sun's radiation. And they convert this into ions and forms ionosphere, and this is the layer, ionosphere is the layer where we find out free electrons, atoms or ions freely there. So this is a very important layer, ionosphere, as far as the atmosphere is concerned. Then this layer is rich in 2 things. One is oxygen atom. The ionosphere layer is rich in 2 things. One is oxygen atom, another one is nitrogen molecules. This point has to be remembered because it is a very important point. And sometimes they ask that photoionization of gas molecules maintain the temperature profile of which atmospheric layer. So this is the same layer which is generally fall under thermosphere, This is a very famous question which they ask generally. So due to the photoionization of gas molecules like O2 and N2, the temperature profile of which atmospheric layer is maintained. So the answer would be thermosphere. And this layer is basically rich in oxygen atoms and nitrogen molecules, which we have mentioned earlier. Then we can have a fact that 90% of the mass of atmosphere lies within 30 kilometer. In fact, 99.9, which we can split like 80% in troposphere, then 19.9% in stratosphere. So in total, up to 50 kilometers or within the first 30 kilometers, starting from troposphere, we have 99.9% of the total mass of the atmospheric gases lying there. If we talk about 80 to 250 kilometer, which we call as ionosphere, this is most important belt of ion, and sometimes the scientist or the researcher also call it as a heavy side layer. And this is the layer of atmosphere which help in radio transmission. As shown in the diagram, we have shown that from 80 to 250 kilometer we have ion belt where we have positively and negatively charged ions. Then suppose from Earth's surface via a transmitter we are throwing some signal in the atmosphere, and this layer will be reflecting back those signals, and a receiver located at another position on the Earth's surface will receive those signals. And in this way, this layer ionosphere help in radio transmission. This do not allow to penetrate and reflect back those signals. Then if we talk about the normal flights and the jet plane, then commercial flight, these all Air India, Indigo, they fly at about 10 to 12 kilometer, which is nothing but troposphere. Upper part of troposphere and jet flights or fighter plane, they fly in stratosphere because there is no water vapor or very negligible amount of water vapor in stratosphere, no weather phenomena, the visibility is maximum, and the friction or the opposing force is minimum. Now we will be talking something about auroras, though this is a least interesting topic from the examiner's choice, but still. Auroras. Auroras is nothing, these are intermittent display of light due to ions present in ionosphere. What happened there is, glues are produced when atoms of oxygen and molecules of nitrogen are energized and emit light on striking with electrons and proton clouds produced by a sun during solar flare activity. This phenomena of aurora is mostly observed at poles and southern hemisphere, and basically we have two types of auroras. One is aurora australis, which is seen in southern hemisphere of Earth. Another one is aurora borealis, which is seen in northern hemisphere of Earth. As you can see, we have shown the diagram of a globe, both northern hemisphere and southern hemisphere, north pole and south pole, where we have shown Arctic in northern hemisphere and mostly land is present in northern hemisphere, and 0 degree you can see is parallel or equator position. And in southern hemisphere we have Australia, mostly water is present in southern hemisphere. Then we had south pole we have Antarctica in southern hemisphere. So this can be understood about auroras. Now we will be talking a very important sphere of the atmosphere, which is called as Magnetosphere. The layer of thermosphere beyond 9,600 km is called as thermosphere. Sometime the examiner asks why it is called as magnetosphere. Because in this layer, Earth's magnetic field can be felt, but there is no atmosphere as such. So because the Earth's magnetic field can be felt at this distance, 9,600 km, that's why we call it as magnetosphere. But there as such no atmosphere is there, no gaseous atmosphere is there. Then there is a very interesting question. People ask why there is no atmosphere at moon. So remember one thing, any planet to have atmosphere, the gravitational force of attraction by that planet to the gaseous molecule which are forming the atmosphere of that planet should be there. And we know that the acceleration due to gravity at moon is 1/6 time to that of acceleration due to gravity at Earth. And the acceleration due to gravity on Earth is 9.8 meter per second square. We know from our elementary classes. Now there comes a term which is called as escape velocity of Earth. So escape velocity basically depends upon under root of capital G, which is gravitational constant, into mass of the planet divided by the distance. And for Earth it comes out to be 11.2 kilometer per second. And it depends upon the value of G. And as the value of G decreases, then at moon where we are having lesser value of G because of lower gravitational attraction, the escape velocity will be less. So all the atmospheric composition of those gases will escape faster and there will be no atmosphere if the value of the G will keep on decreasing. Then generally there is a classification about ionosphere also. This is a very trivial kind of classification. There are different layers in ionosphere which are basically D, E and F layer. All the layers D layer, E layer, F layer of ionosphere are present in daytime, but only F layer is observed in night time. So this classification of ionosphere is not very important. We just need to remind it that there are three layers which are formed in ionosphere: D, E and F layer. All the three D, E and F layer are present in the daytime, while only F layer is present in the night time and D and E layer are absent in the night time. Hope you enjoy today's session with A.S.S Science Foundation, Delhi, and it will help in making your understanding better about the structure of atmosphere. Thank you.